we see a diagram here. It is made up of a rectangular wall, and inside is all laid up with hexagonal tiles. And each hexagon is a side of 6 meters. Okay, so when we see regular, okay, not only means same length, okay, it means that all sides and also all the angles are equal. Okay, so this is your regular hexagon. So I'm going to draw out one of the hexagons here. And I'd like to zoom in to look at one of the triangles. So we know that each of the side is 6 meters. Okay, so this side, this side, this side, they are all the same. So if I were to find the whole length from one end here to the other end, this is 6 and this is 6, right? So it would be 12 meters. Okay, then this part here would be 6 as well. I'm going to further zoom in to look at this particular triangle, and I'm going to drop a perpendicular line down to make a right angle. Okay, so when you drop a perpendicular down, it's going to cut this line exactly into 2. So this will be 3 and this will be 3. Okay, so I'm going to draw out this right angle triangle here. This is 6, this is 3. And we also see that in the diagram, one of the heights, or rather the height of one of the hexagons is given as A. Okay, so now I'm taking only half of the height, which is here, right? So that would be half A. I'm going to write down here. Okay, so that forms our right angle triangle with 3 of the values and one of the variable is here. So half A, 6 and 3. Okay, since this is a right angle triangle, I'm going to make use of Pythagoras Theorem to help us solve. Okay, so by the Pythagoras Theorem, okay, so we see that half A, the whole thing square, plus 3 square is going to give you 6 square. Okay, so the sum of squares of the two shorter sides will give you the square of the longer side. So half A square, I'm going to expand and open up, so it will give you 1/4 A square. 3 square is 9, 6 square is 36. 36 minus 9, that's 27. A square is 27 times 4, so 108. A would be root of 108, okay, and you can press your calculator. It's going to give you this number. And rounding off to 3SF, I get 10.4 meters. This is your part A. Part B, you're asked to calculate the shaded area in square meters. We are already using meters, so we do not need to do any conversion. Okay, so to find the shaded area, our plan would be to take the area of the rectangle minus away all the unshaded parts, which is the unshaded hexagons. Okay, so you will get the shaded area. So let's first find the area of the rectangle. Okay, so let's look at the diagram again. Okay, so we see that, let's look at the length first. So the whole inside length here is 12, right? Okay, and each of the side is 6. So this is 12 and this is 6. So you see that it follows a pattern. Okay, so this whole length here is made up of 5 12s and 4 of the 6s. Okay, so total it will give you the length of 84 meters. Okay, we see that the height of each hexagon is A. So you see there are 3 hexagons here which forms the breadth. So the breadth will be 3A. And we have found A earlier. I will just use this square root number. So I will take it as 3 and square root of 108 as my breadth. Let's write down the area of the rectangle. Okay, so length times breadth, I'll take 84 times 3 root of 108. Okay, so 84 and 3, they're whole numbers. You can multiply them together. You will get 252. And I shall leave the square root of 108 as it is first. Okay, next, let us look at the area of the unshaded hexagons. Before we look at the total area, let's find the area of one hexagon first. Okay, we're actually looking at unshaded ones, but unshaded or shaded, they both have the same area. Okay, I'll draw this hexagon by the side one more time. So to find the area of one hexagon, you can either take the area of one, I'm going to come back to here first. You can find the area of one small triangle here and you multiply by 6. Or I'm going to show you another method here. That is, I'm going to divide it into half. Okay, and each part here is actually a trapezium. So one hexagon is actually equals to 2 trapeziums. Okay, we know that this length here is 12, this is 6. Okay, and the whole height here is actually A. But I'm going to use half of it first. Okay, so half of it is actually half A. Okay, I'm going to use area of the trapezium and then times 2. So recall what is the area of a trapezium. It is given as half times sum of parallel lines times height. Okay, so I'm going to do that. So half times sum of parallel lines. Parallel lines, I have 6 plus 12. Height is half A, which is half of root 108. And this whole thing, I'm going to multiply by 2 because there are 2 trapeziums. Okay, I'm going to open up and solve. Let's look at the inside bracket first. Okay, so inside I have half times half, that gives me 1/4, and 6 plus 12 gives me 18. So 18 over 4, I'm going to reduce it and get 9 over 2 root of 108. So as you can see, the 2 will cancel out, and this is one hexagon. Okay, coming back to the diagram again, when we look at the unshaded hexagons and you do a quick count, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so there are 18 of them. Okay, so area of the unshaded hexagons. Take 18 times your 9 root of 108. That's going to give you 162 root of 108 square meters. Now we can go on to find the shaded area. So shaded area, take the area of the rectangle, which is 252 root 108, minus away your area of the unshaded hexagons, 162 root of 108. And notice that these two terms both contain the common factor of root 108. So I'm going to take it out as a common factor, root 108, 252 minus 162. So I get, in the brackets, when you minus, you get 90, 108. Okay, then you can press your calculator. (953.37). Round it up, you will get 953 square meters in 3SF. Okay, and I would also like to show you how you can simplify this square root number here. Okay. Oh, sorry, it should be 935. Sorry, 935 instead. Okay. Okay. I'll show you how to simplify this because you see that the answer here is 540 root 3. You can simplify your 90 and root of 108 to be like this. So 108, I can break it up into 36 times 3. Okay, and I can take square root of 36 and square root of 3 separately. So square root of 36 will give you 6, right? And square root of 3 is going to give you an irrational number. So I will just leave it as square root 3. So 90 times 6, you get 540 and root 3. Okay, so this is how you get this. So just in case you are asked to show that your answer looks like this in the exam, you are able to break down your numbers like that and get to this. So 540 root 3 square meters. So it's possible to leave your answer like this, okay? Or you can just simply leave your answer as 935 in 3SF. Okay, so this section you have a worksheet 3. Okay, so the solutions have been stapled together with your worksheet. Okay, so you can refer to it. Try to work out on your own first. Refer to it if you're in doubt, or you can ask me in class when you come back next week. I'll stop here.